Well, hello there. My name is Rob, and I'm a graduate student at MIT studying plant biology. This is the first of many deep dives in 700X, where we'll cover topics introduced in lecture in greater depth, or cover new biological problem-solving techniques. So this first dive will be how to read a chemical structure. Let's dive right in.
All right, I'm showing you the periodic table, and you'll notice that certain elements are highlighted in green. We've got hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. So why did we highlight these? These are the most important types of atoms found in biological molecules. You'll be seeing quite a bit of them throughout the course, so let's get properly acquainted. Each of these types of atoms is governed by bonding rules. So, for example, let's start with hydrogen. Hydrogen likes to form a single bond with another atom. We depict it with this line. Whereas carbon prefers to form 4 bonds, that means 4 lines. Nitrogen likes to make 3 bonds, and oxygen likes to make 2 bonds. So using these bonding rules, we can now construct larger molecules or combinations of these atoms. So let's take a look at one. This is a depiction of caffeine, the world's most consumed stimulant. You'll notice a couple of types of atoms, nitrogens, oxygens, but you don't see any carbons or hydrogens. But they're definitely there. Interesting. What's the story here? This drawing is a shorthand depiction of the chemical structure. Chemists and biologists love using this type of shorthand, but it takes a little practice to get used to it. There's a couple of rules you have to follow. Rule 1 is what I like to call carbons at the corners. What do I mean by that? Carbons are found at any corner or the end of any line. So, for example, corner, carbon. End of a line, carbon. We can follow that pattern all the way around in this molecule. Any place where there is a line that doesn't already have an atom depicted at the end of it, we know there's a carbon. So in this case, we have 2, 4, 6, 8 carbons. Rule number 2, hydrogens bonded to carbons are implied. What do I mean by that? I mean that these carbons are supposed to be bonded to 4 different things, if you remember our bonding rules. And some of these don't have 4 bonds yet. So this one, we can count 1, 2, 3, 4. It already has all 4 of its bonds. It's following the bonding rules, so it's happy as is. Whereas this carbon, not so much. We need to add 3 bonds to give it its full complement of bonds. And each of these bonds will be to a hydrogen atom. We can go around and do the same for each of these. This one has 4, it's happy. This one has 1, we need to add 3 more. This one has 4, this one has 4. This one has 1, so we'll add 3. This one has 1, 2, 3, and needs a 4th. Squeeze that hydrogen right in there. Well, look at that. All of the carbons and hydrogens were actually hiding in plain sight. And now you know the way to find them. So now we can write out a chemical formula. How do we do that? We tally up how many atoms of each type make up the molecule, and in this case, if we count out the carbons, we have 8. If we count out the hydrogens, we have 10. What about nitrogens? I see 4. Oxygen, I see 2. C8, H10, N4O2. Bingo! That's our chemical formula.
So let's take a look at another molecule. I'm showing you here the chemical structure for the painkiller aspirin. Remembering our rules for carbons and hydrogens, pause the video for a moment and try to figure out what the chemical formula is.
Okay, did you come up with your answer? Let's go through it together. First off, what are the types of atoms that we have here? We have a whole bunch of carbons, even though there aren't any C's visible. We have hydrogens, and we have oxygens. I can't find any other types of atoms. So let's figure out how many carbons we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons at the corners. Great. What about the hydrogens? This hydrogen is written out explicitly because it is bonded to an oxygen. So we already know that one. But all the rest are bonded to carbons, and we have to find them. This carbon has 4 bonds, this carbon has 4 bonds, and this carbon has 4 bonds as well. They don't need any hydrogens added. This carbon has 1, 2, 3 bonds already, so we need a 4th. Add a hydrogen. This carbon has 3 bonds, so the 4th goes to hydrogen. These next two carbons in the ring have 3 bonds as well, so we'll add a single hydrogen at each carbon. This one already has 4 bonds. This one needs 3 additional bonds, so let's add 3 hydrogens. Voila! That adds up to 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So what about the oxygens? These are easy. Just count them up. 1, 2, 3, 4. 4 oxygens. You should have gotten C9H8O4 as your chemical formula. If you did, bravo!
Hopefully, you now feel more confident about your ability to read chemical structures. Going forward, we're going to use our knowledge of chemical structures to try and predict how chemicals behave. Until next time.